Hello, and thank you for having me. This presentation is called Human-Governed Agentic AI, Turning Fragmented Legacy Data into Trusted Workflows. Before I start, a little bit about me. My name is Marcelo Bursztein, and I'm the founder and CEO of Novacine AI. We specialize in applied AI for regulated organizations. Today in the presentation, I will cover the stall problem, or why AI initiatives lose momentum before delivering value in production, the root causes that lead to that stall problem, including data issues, gaps in governance, and explainability. I will present the governed agentic workflow model, a 4-component operational model for AI in regulated environments. We'll talk about the patterns that are part of this model, including autonomy, escalation techniques, traces, and audit logs. And finally, I'll talk about a practical methodology for scalable pilots before moving to production. So let's start with something that most of you already know as a lived experience. Your organization has invested in AI. There have been workshops, POCs, dashboards that look fantastic in meetings, but yet things slow down. The ROI that seemed so obvious during demos hasn't really materialized at scale. So this is not a technology problem, a lack of ambition, but rather it's a pattern that we see repeating itself across industries, geographies, and company sizes. I call this the operational gap. That's the distance between what AI can do in a controlled environment versus what it actually delivers in a complex, regulated environment with an abundance of legacy data. So let's look at this operational gap. The conventional response to this gap is usually one of two things. Either we need better models, or we need to modernize our systems before we can roll out AI. Both of these miss the point. The model is rarely the problem, and the idea that you need to replace your entire core system before AI can work, that's not really a solution. That's a multi-year, multi-million-dollar detour that organizations cannot afford to take, and many have tried and regret it. So, the real bottleneck is operational readiness. Specifically, 3 things. First, data is fragmented, siloed, and locked inside systems that were never designed to talk to each other, and much less to power AI workflows. The second bottleneck is that workflows require AI to make decisions that carry regulatory, financial, or human consequences, and therefore, those workflows need governance that most AI systems simply don't have. And the third is the absence of human oversight. AI that operates as a black box without any meaningful checkpoints simply cannot be trusted by the business. As we know it well, if the business doesn't trust AI, they will not adopt it. So, what I want to share today is a practical approach that addresses all of these bottlenecks, not by replacing systems or waiting for the perfect data, or even removing humans from the equation, but rather by making data AI ready, by designing workflows with governance that is built in from the ground up, and by treating human oversight not as a constraint, but as the very thing that makes it trustworthy enough for it to be adopted across the organization. But before we look at the approach, let's dive one layer deeper into each of these root causes. Let's look at the first one, data fragmentation. Most organizations don't have a data problem in the sense that they have too little data. They have a data integration problem. Information does exist in decentralized systems like CRMs, ERPs, case management systems, spreadsheets, documents, and legacy databases that have been running for 20 years and sometimes 50 or even 100 years. So when an AI needs to put together context from many different systems to support one single decision, and each of these systems speaks a different data language, that's when things break down. It's not the model, it's the pipeline or the plumbing. Making AI-ready data doesn't require a data lakehouse or a wholesale data migration. It requires more targeted efforts. First, normalization, which means bringing data into a consistent representational form that AI workflows can consume. It also requires lineage, which means knowing where each piece of data came from, when it was last updated, and what transformations it has passed through. Without lineage, you can't audit. And without auditability, the business simply can't accept the output. And it requires contextual accessibility, meaning the ability for an agent at query time to retrieve the right data for the right decision without having to ingest everything upfront. So, this is achievable incrementally. You don't need to solve for your entire organization before AI delivers value. You solve it domain by domain, workflow by workflow. So let's look at the root cause number 2, governance. Governance is typically something that is bolted on after the fact. An AI system that is built, it performs well in testing, and then somebody asks, but how do we know that this decision is correct? How do we explain this decision to a regulator? Or how do we know what to approve and when? At that point, retrofitting governance is painful and often results in an incomplete implementation. In high-stakes environments like financial services, healthcare, or government, AI decisions often have downstream consequences for individuals. Those decisions need to be traceable, not just technically, but in plain language, so that an auditor or a business user can understand. Governance has to be designed into the workflow from the start. It cannot be report generated at the end. It needs to be a living record of how a decision was reached, what data was considered, what rules were applied, and where humans intervene in that decision. And finally, that brings me to the root cause number 3. This is the explainability deficit. There's a version of explainability that lives in research. Think of attention weights, for example, or feature importance in machine learning. And that version of explainability has its place, but in an operational environment, explainability means something different. It means that a frontline employee can understand why the AI is recommending a particular action. It means also whether they can push back on it if it seems wrong, and whether a compliance team can reconstruct or reproduce the reasoning after the fact. If the answer to any of these questions is no, then you have an explainability deficit. And that deficit will become a barrier to adoption. So the good news is that explainability at this operational level is entirely achievable. It's a design question and not necessarily a technological limitation or a fundamental limitation of the system. So given those root causes, what does a practical solution look like? I want to introduce what I call the governed agentic workflow model. It has 4 components that operate in concert. Number 1, an AI-ready data layer. Second, an orchestration layer. Third, a human oversight layer. And the 4th pillar is an audit and explainability layer. The AI-ready data layer is the foundation of the system. Its job is to make fragmented legacy data usable by agentic workflows. This means building connectors that extract, normalize, and contextualize data from different systems. It means applying schema mappings so that related data points resolve to the same entity, and it means creating metadata that travels with the data through the workflow. The second component is orchestration. The orchestration layer is where the behavior lives. An agentic workflow is a coordinated sequence of AI-driven steps. Gathering data, for example, applying rules, generating outputs, and evaluating outcomes. Together, these constitute an insight extraction process. What makes orchestration different from traditional robotic process automation or RPA is its adaptability. A traditional workflow follows a fixed path. An agentic workflow can reason about which steps are needed given the current context. It can handle variability. But, and this is important, adaptability doesn't mean full autonomy. The orchestration layer operates within defined boundaries. It knows which decisions it can make independently and which ones require human input. Those boundaries are calibrated to the risk profile of each decision type and use case. Component 3, the human oversight layer. This layer is embedded into the insight extraction loop at predetermined checkpoints. If a human reviewer only reviews AI outputs after the fact, they are in validation mode. Checking whether something the system has already done was correct, for example, while useful, is not control. When human oversight is embedded into the workflow itself, you have a system where human judgment shapes the outcome. Designing this oversight requires deliberate thinking about which decisions carry enough uncertainty or consequence to require a pause. Not every step needs human review. That would certainly defeat the purpose. But the right steps with the right framing of what the agent has done and why allows the human reviewer to add value very quickly. This also is the mechanism through which the system learns over time. Human decisions at oversight points create expert feedback that can be used to refine agent behaviors as the system evolves. And finally, the last and fourth component, audit and explainability layer. This layer, I would argue, is what makes the entire operating model viable in a regulated environment. Every action taken by the agentic workflow, every data retrieval, every prediction, every rule applied and routing decision is logged. A structured record of what happened, in what sequence, with what inputs, and what rationale. This record serves multiple purposes. For compliance teams, this is the audit trail. For the business, it's the explanation that gives them confidence. And for AI governance functions, it's the data that monitors drift, bias, and unintended behavior. With explainability being the byproduct of the workflow itself, it becomes both more accurate as well as scalable. So, while the governed agentic workflow model is the framework, what makes it real are these repeatable design choices that teams can apply across different domains and use cases. Here are the 4 patterns that appear consistently in successful deployments. The first is tiered autonomy. Not all decisions carry the same risk. A pattern that works well is to classify decisions into tiers. Low-stake decisions, the agent executes autonomously. Medium-stakes decisions, the agent recommends and a human confirms. And high-stakes decisions, the agent provides structured analysis, but the human owns the final call. The key discipline here is that tier assignment is not static. It should be calibrated periodically based on observed outcomes, error rates, and changing regulatory expectations. A decision type that starts in Tier 2 may move to Tier 1 as trust is established, or it may move to Tier 3 if a pattern of errors emerges. Pattern 2 is confidence-gated escalation. Agentic workflows can be designed to self-assess uncertainty and scale accordingly. If the agent's confidence in a recommendation falls below a defined threshold because the data is sparse, conflicting, or outside of the training distribution, it flags this explicitly and routes to human review. This should not be seen as a limitation, but rather a feature. A system that knows what it does and doesn't know and communicates that clearly is a trustworthy system. In regulated environments, the ability to surface uncertainty honestly is as important as the ability to generate accurate answers. The third pattern is plain language reasoning traces. Rather than exposing raw model outputs, a well-designed agentic workflow generates structured summaries of the reasoning in language that a non-technical reviewer can evaluate. This is a design choice. It requires intentional prompt engineering and workflow structuring, but it is entirely achievable with current generation models. When a human reviewer sees not just the recommendation, but why the recommendation was made, they can make a meaningful decision in seconds rather than going deep into a larger review. Pattern number 4, immutable decision logs. Every decision event, including the agent's reasoning, the human reviewer's action, and the timestamp, are written to an append-only log that cannot be altered retroactively. This is the operational equivalent of a chain of custody record. It creates the conditions for regulatory auditability, and it also creates the data infrastructure for continuous governance, monitoring the performance degradation, identifying systematic errors, and detecting anomalies before they become incidents. Taken together, these 4 patterns, tier autonomy, confidence-gated escalation, plain language reasoning, and immutable decision logs, constitute a governance architecture that allows AI to operate ambitiously without operating recklessly. Let's talk now about moving beyond pilots. This is a proven, scalable methodology. Everything I've described today is achievable incrementally. You don't need a perfect data architecture before you start. You don't need to resolve every governance question before the first workflow goes live. And you don't need organizational consensus on AI strategy before a single team can begin delivering value in production. What you do need is a methodology that scales, one that treats each successful workflow as a proof of concept for the next. One that builds trust with frontline employees, compliance teams, and regulators through demonstrated reliability. So, what does this look like in practice? Well, in practice, this means starting with a well-scoped workflow, one where the data exists, the decision logic is understood, and the human oversight points are clear. It is not your most complex workflow. Rather, it's a process where you can show measurable impact within months, not quarters or years. It means investing in the data layer first, because everything else really depends on it. But don't try to boil the ocean. Solve the data problem for this particular workflow in this domain for this decision type and this use case now. And it means designing for trust from day one. Explainability, auditability, and human oversight are not features you add before you go to production. They are the conditions under which production is possible. So, the organizations that will lead in the next 5 years are not those with the most sophisticated models. They are those that figured out how to make AI operational inside real systems with real data and with the trust of the humans and regulators that depend on it. That is the work. And the good news is that the patterns exist. The path is clear. What remains now is execution. Now, shifting over to the Q&A. There are 2 questions that I will address here. The first one being, how can organizations make fragmented legacy data AI ready without large-scale system replacements? That is a great question, and I want to be direct. The premise that you need a modern data platform before AI can work is a significant misconception, and it's one that has caused organizations to delay meaningful AI deployments by years. The alternative is what I would call incremental data readiness. You don't need to transform your entire data estate. You build targeted adapters, lightweight integration layers that normalize and contextualize data from source systems for specific workflows. The discipline here is scope. Rather than trying to make all of your data AI ready, you ask, what data does this specific workflow need? What does that data need to look like? And what problem are we trying to solve? Then you solve it again for the next workflow. Over time, you accumulate reusable patterns and components, and the data layer becomes progressively more capable without ever requiring a big bang transformation. The other thing I would like to emphasize is that data lineage matters as much as quality. An AI system that can explain where its information came from is far more trustworthy and auditable than one that can't. Build lineage in from the start. The second question is, what role does human oversight play in ensuring trust, explainability, and compliance in an AI workflow? Human oversight, in my view, is not a constraint on AI capability. It is a mechanism through which AI capability becomes trustworthy enough to matter and to get adopted. Here's a reframe I would find useful. The question isn't how much human oversight can we remove as AI gets better. The question is, how do you design a human oversight layer so that it adds genuine value at every point where it operates? In practice, this means three things. Number one, oversight needs to be positioned at meaningful decision points, not as a rubber stamp at the end, but as a genuine input into the decision process. Second, reviewers need sufficient context to make meaningful judgments quickly. That's where plain language reasoning traces matter enormously. And third, every human decision needs to be captured because it creates a feedback loop that improves the system over time. And it's the audit trail that satisfies regulators as well. Trust in AI systems from employees, customers, and regulators is not built through capability demonstrations. It is built through consistent, transparent, and accountable behavior over time. Human oversight is the mechanism that makes that possible. And in regulated environments, it is also non-negotiable. Thank you all. This has been a fantastic session to be part of. And if you want to continue the conversation, you can find me at the coordinates on the screen. Thanks again.